So I've been interested in space since I was a little kid. I got a picture sent in the mail of the first space shuttle launch out of Kennedy Space Center, and that really hit me. It hung in my bedroom since I was a kid, and then it was just a matter of watching that space program grow. I went to space camp both 6th and 7th grade and started flying an airplane at about 10 years old. Building a small satellite based on an MRI principle, I ran into the actual bottleneck in the launch industry, which is 4 to 7 years to get on a rocket. So a lot of the CubeSats are secondary payloads, and they have to wait and they get bumped off of rockets. And I approached my 5-year-old daughter and I said, look, it's gonna take us about 4 years to get into space and about $2 million. And my little 5-year-old daughter, Belladonna, looks at me and goes, well, sounds like we have to actually build a rocket now. So we started building Stofiel Aerospace and the Boreas system. Our launch system is innovative because we 3D print and scale the actual rocket to the payload versus other systems that the payload has to scale into the rocket. We're a rockoon, which means we fire off a balloon at 100,000 feet. We're mobile. We can launch from almost anywhere in the world. I like to say that I could take my balloon rocket out to the middle of the parking lot and launch it from there. And we're a solid rocket, which means we can be mass produced and stored for up to 10 years. We are 3D printing on a PLA plastic thrust systems and putting live rockets through them. And that's a pretty big advancement because now if we can keep this development up, we no longer have to have the metal nozzles that are very heavy, the metal casings for the rockets that are very heavy, and we've lightweighted the system up. To date, we are surviving 3,000 degrees Celsius and about 10,000 PSI. We've also developed a heat coating that may allow us to use those plastic nozzles instead of the more expensive, heavier titaniums and aluminum alloys. Our biggest achievement to date is being able to quick prototype nozzles. We can produce a nozzle and fire it within a week using basic equipment. Our motto is fly high, burn hard, but really the unofficial motto is you bring us your payload on a Monday and we have it in orbit by Friday. That on-demand access to the aerospace industry. St. Louis has always been a hub of exploration. The space industry started here as a commercial industry. So Mercury and Gemini were built by McDonnell Douglas here in St. Louis. So we're doing the same thing that the Maxold team had to do. They didn't know anything about space flight, so they had to develop the technology by experimentation through Redstone, through Mercury, and through Gemini. Maxold team has been a mentor to Stofiel Aerospace during our experimental methodology in order to collect data points. Because they did experimentation just like we do.
He's doing something that has never been done before, and that is a common bond with us. It's the kind of thing the engineers think of. It's a novel way to do something that needs to be done. It's just such a novel idea. I really admire him.
Our rocket Hermes, we don't know how the fluid dynamics works yet, but we know it works. And that's where we're at, is we're actually doing the experimentation to understand how it works. What you got in your hand, you got your rocket rods. We're also involved deeply with the STEM outreach here in St. Louis. The other part of that is we're tapping into the education here inside St. Louis, so St. Louis University and Washington University. St. Louis University is already an expert in CubeSats, and now they need a launch system. Stofiel Aerospace's goals for 2018 are to have flight trials this year of the Hermes rocket and actually put rockets above the Kármán line and around 4,000 miles an hour or hypervelocity. And we're going to test some of the Boreas satellite systems. The Hyperion and Artemis are going to be tested in flight trials, and we would like to get to the point where we're actually taking investments. So in 5 years, Stofiel Aerospace would have opened up the launch capabilities for small satellites. And we could see 1,000 launches out of the Boreas system in the first year. In the longer term, the 10 to 15 years, we're looking at a geological spectral analysis survey of the asteroid belt, and we consider that generational data that we can sell for a generation to these asteroid miners. Our eventual goal for the company is to go to the Saturn system, and we think there's a lot to be explored and actually exploited inside that system. There's so many interesting places to go in Saturn, and it's a benign environment compared to the Jupiter system that we've made it our primary target over Mars even. So venture capitalist funding would accelerate us because we're bootstrapped at the moment, and this has slowed our growth in R&D. It would also allow me to bring my team on full time and actually do a 40-hour week with everyone involved. Every day is a little step forward in order to keep this motivation going. What really gets me motivated is seeing the data that we're producing from very inexpensive testing. Meeting the legends of the space industry like the Max Old team and Buzz Aldrin, and being able to interact with the kids and see their excitement to the 3D printing, to the drones and that type of technology. Stofiel Aerospace was founded by military veterans. They don't ask us if it's possible, they ask us how are we going to do it. And that's a big thing for an inventor and an engineer that's starting a company. So my daughter Bella has been part of this since the beginning, going to business meetings, doing rockets, 3D printing, and all the STEM outreach also, and actually testifying in front of the Ohio Aviation and Aerospace Technical Committee. We went to NASA Glenn, and to quote my daughter Bella, we are space cowboys and we aim to misbehave.